Wait, no. Woohoo! We're finally streaming and we're going to be learning Rust again. I've been fucking around with Lua the last couple of, well, minutes, seconds, times, hours, I don't know. Kinda tired of it, unsurprisingly. Like, I do hate Lua, after all. And even though I created some very useful things, I don't like working in it. It's just not very nice. So, what we're gonna do is, where was it? In reg L. Here we go. Okay, yeah, I guess that works. Does this chat still work? I imagine so, right? Okay. Fuck, let's start. Yeah, this is far more exciting than fucking Lua. The option enum and its advantages over null values. Immediately I'm like, why could it be better? You're implementing a whole entire type instead of the sentinel value of a boolean, pretty much. But well, let's see. This section explores a case study of option, which is another enum defined by the standard library. The option type encodes the very common scenario in which a value could be something or it could be nothing. For example, if you request the first item in a non-empty list, you would get a value. Ah, yes. Right on schedule. I start streaming, my cats start meowing. Oh, interesting, and it reverted to top chat. So top chat hides some messages, and I'm not sure, like, of the filtering that it does. It's very unclear. Oh my god. I'm gonna feed them. I hope they're not gonna meow anymore. Okay. You would get nothing. Expressing this concept in terms of the type system means the compiler can check whether you've handled all the cases you should be handling. This functionality can prevent bugs that are extremely common in other programming languages. True. Programming language design is often thought of in terms of which features you include, but not the features you exclude are important too. Rust doesn't have the null feature that many other languages have. Null is a value that means there is no value there. Honestly, I think that's very much fine. Like, that's fine. We just pick a sentinel value that we can trust is a sentinel value, and here we go. In languages with null, variables can always be in one of two states, null or non-null, or not null. Oh, yeah, you're right about that. That's a good point. You never know if a variable is null. You can check, but you might still miss some situations where that variable becomes null. That's a good point. And I guess in Rust, it's made explicit that some variable or value can become null. That's an interesting distinction. In his 2009 presentation, Null References, the $1 billion mistake, lol, Tony Hoare, so his name is literally Hoare, that's hilarious. Usually it's like low to make fun of someone's surname, but come on. The inventor of null has this to say: I call it my $1 billion mistake. At that time, I was designing the first comprehensive type system for references in an object-oriented language. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler, but I couldn't resist the temptation to put in a null reference, simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably cost $1 billion of pain and damage in the last 40 years. Yeah, but it's kind of like prison abolition, which I know is a crazy stretch, but in prison abolition, first time you hear the idea, you're like, all right, yeah, I mostly agree, but we still need a prison for those extra freaky people. And right now I have the same thought about not having null at all. Like, sure, you can remove most of it, but still, we kinda do need null, don't we? So thinking about this like this is probably similar to trying to recreate the prison when you're faced with the question of prison abolition. But it seems like there is a null, it's just more explicit. The problem with null values is that if you try to use a null value as a not null value, you'll get an error of some kind. Because this null or not null property is pervasive, no idea what that means, let's check. Pervasive, especially of an unwelcome influence or physical effect, spreading widely throughout an area or a group of people. Oh, so like, it's all over the place. It's extremely easy to make this kind of error. Yeah, it's true. So, usually, I'll bring into example C#. Its null and not null things are like fine. And usually it will scream at you if a value can become null, but you don't specify it. But still, dealing with it in C# feels very annoying, because of which you'll often see like question marks at the end of things and exclamation mark as well, to mean I don't care that this becomes null, fucking do it anyway. Which kind of defeats the point, right? Like, this can become null. If it does, oh well. Maybe that's just the code that I've seen, but it seems like it's not that uncommon, which is like, damn. And having to deal with null at every point is very annoying. I do hope that this, and overall the structure of the Rust language, will help this entire situation. However, the concept that null is trying to express is still a useful one, and null is a value that is currently invalid or absent for some reason. It's incredibly useful. So AHK doesn't have null. It has unset, which is a very different thing, because unset is not a value, it's a state of the variable. So you can't return unset. So if you need to sentinel value in a function, you just have to like make up your own, like -1 for example, which is like that sucks. I would rather have null. The problem isn't really with the concept, but with the particular implementation. As such, Rust does not have nulls, but it does have an enum that can encode the concept of a value being present or absent. This enum is option T, and it is defined by the standard library as follows. Okay, so it could be none or literally any value. Interesting how enums work, by the way. That's interesting. The option T enum is so useful that it's even included in the prelude. You don't need to bring it into scope explicitly. I don't think that matters that much. Like, including a few things before you start a program is fine. It doesn't really matter. And most likely, you can press... Well, let's actually try this out. Opening a project where that is the case is too long. I know, init.lua. So I like go to some line and no, not this. Let's try to search for code actions because I'm talking about them. Really? No code actions. Not at all. Okay, let's jump to this function, make local. Really? Really? I'm pretty sure. I know. Diagnosed this. If we remove this line, it now screams code actions. Here we go. So most likely, if you're trying to use something that you didn't bring into scope, there will be a quick fix that you just like press tab on and it does the entire thing for you. So for the most part, I don't really care whether or not I need to bring things into scope. It's fine as long as it's in the standard library usable. If it's an external library, I may consider not using it depending on the situation. But with Cargo and how well it's working, that's probably not as much of a case as it is in other languages. In C#, for example, if I'm bringing in a library, that's like a whole entire operation. In Rust, it feels, at the very least, far more modular and easier. The option T enum is so useful, yeah. Its variants are also included in the prelude. You can use some and none directly without using... Hold up. Hold up. That's just null with extra steps. Literally. Yeah. So you have null, but it's implemented a bit differently. Okay. Some and none directly without using the option prefix. The option T enum is still just a regular enum, and some T and none are still variants of type this. Huh. Huh. The T syntax is a feature of Rust we haven't talked about yet. It's a generic type parameter, and we'll cover generics in more detail in chapter 10. For now, all you need to know is that T means that the sum variant of the option enum can hold one piece of data of any type, and that each concrete type that gets used in place of T makes the overall option T type a different type. Yeah, I know generics from C#, so I kind of get how they're supposed to work. Here are some examples of using option values to hold number types and string types. I see. Yeah, that's pretty easy. That's pretty cool. Oh, I see what's the positive of this. When you use sum, the type of the type of sum char, for some reason sum looks really wrong to me, like it's not a real word. The type of sum char becomes option like this. Even though you only used one variant of it, the type is still correct, meaning some char can now become none. That's actually, yeah, that's good. So things are still explicit on whether or not they can be nullable. Hello. We're learning Rust today. Again, not fucking Lua. The type of some number is option I32. The type of some char is option char. True. Which is a different type. That's also good. Rust can infer these types because we've specified a value inside the sum variant. For absent number, Rust requires us to annotate the overall option type. The compiler can't infer the type that the corresponding sum variant will hold by looking only at a none value. Here we tell Rust that we mean for absent number to be of type option I32. Yeah, that makes sense. And in a similar fashion, we could annotate the type here with the not integer 32, for example, but maybe I8 or U8, if that makes sense for us. Okay, yeah, that's not bad. When we have a sum value, we know that a value is present and the value is held within the sum. When we have a none value, in some sense, it means the same thing as null. Yeah, we don't have a valid value, so why is it any better? It feels better because it's a specified type and it's explicit whether something can become null or not when it's not. No, I guess C# does guarantee it, to be fair. Maybe I'm just kind of bad at C# because I think that it's bad there. No, I think my issue with C# and null is the wow, that took a long time, is this standard. The fact that brackets are on a separate line, making any small null check a huge fucking block. And because it's so annoying, you don't really want to do it, and you do it less. Then in a language that is normal and has the opening bracket on the same line, and Rust is even better with this because if statements and so on are not statements, they're expressions, meaning you can immediately check for null with a match statement and then use that value to call another method, which is really big, incredibly big, ginormous, huge even. In short, because option T and T are different types, the compiler won't let us use an option T value as it were definitely a valid value. For example, this code won't compile because it's trying to add an I8 to an option I8. Oh, that's interesting. Because Y can potentially be none. Huh? Okay, let's read it. Can't. No, because there are different types. The trait is not implemented. Huh. That's strange. Intense, I agree. In effect, this error message means that Rust doesn't understand how to add an I8 and an option I8 because they're different types. That's pretty annoying. When we have a value of a type like I8 in Rust, when you have a value of a type like I8 in Rust, the compiler will ensure that we always have a valid value. we can proceed confidently without having to check for null before using that value. True. Only when we have an option 8, or whatever type the value we're working with, do we have to worry about possibly not having a value, and the compiler will make sure that we handle that case before using that value. Ah, I see. Because at this point, it could be null. So now we need to convert its type into just I8 without the option. And if it's null, we do something. That's how you do it. That's interesting. Huh. Confidence is actually so big. Sometimes I write code and then I run it, like almost looking away, and it works, and I'm surprised. That is bad. It shouldn't happen like that. Like, when you run code, you should be absolutely fucking certain that, yeah, obviously it works correctly. When you're surprised that it does, yeah, that's weird. That's because you don't have enough guarantees to be confident in the code that you wrote. Because some things may be incorrect, but with something as small but important as handling every single null, you have a guarantee that nothing weird will happen. Kinda. To some extent. I'm sure, like, Rust, as any language, will still move you into situations where you are encountering weird behavior, but it will be more understandable. In order to have a value that can possibly be null, you must explicitly opt in by making the type of that value option T. Then, when you use that value, you're required to explicitly handle the case when the value is null. Everywhere that a value, that's a strange beginning of the sentence, has a type that isn't option T, you can safely assume that the value isn't null. This was a deliberate design decision for Rust to limit null's pervasiveness and increase the safety of Rust code. I love how we've seen multiple times already. This was a deliberate design decision, basically responding to all the "that's so stupid" that people may think when reading the book. They say, this was deliberate. We know you may be mad, but this is by design, not because of our stupidity, necessarily. But surely Rust has some stupid things. Well, we'll see them eventually. So how do you get the T value out of a sum variant? Good question. When you have a value of type option T, so that you can use that value. The option T enum has a large number of methods that are useful in a variety of situations. Interesting. You can check them out in its documentation. Becoming familiar with the methods on option T will be extremely useful in your journey with Rust. Let's similarly... Oh, I love this. Oh, I love the design. It's so beautifully gray. What the fuck? Oh my god, that's great. Click or press capital S to search. Does it work? Oh, that's so cool. Oh my god, it's like keyboard shortcuttable. I would expect slash instead of S, but S is good too. Okay, yeah. Public. So we can specify, oh, that's good. No value, some value of type T. Implementations returns true if the option is a sum value. Oh, that's interesting. So this is a method, and we know this because of the self returns to Boolean. So we can like do, actually, let me open the actual project. Oh, and this we can close. Let's go to Rust, and then where are we? Test project, and open it in VS Code. Jesus, sure is taking its time. Pretty sure Rust takes a longer time. Oh yeah, much longer time to boot up compared to C#. But that also means that you get more help, I'm pretty sure. So that's quite nice, actually. Okay, and by the way, I love how the logo looks. That's by an extension I have downloaded. And this should be... Hold up. Yeah, in this thing, C# doesn't work, but in every other one, wait, that's not what I want to do. Okay, let me explain what I want to do. I want to okay, let's enable it. And let's, yeah, disable. And then anytime I specifically need C#, I enable it. Let's do the same thing for IntelliCode. Yeah, disable by default. So yeah, I was talking about material icon theme. That's the icon theme that I'm using. Looks very nice in my opinion. Prettier. How often do I actually need it? Let's look at what languages it supports and which one of them I actually use. JavaScript, not really. TypeScript, not really. Flow, what the fuck is that? G6, what the fuck is that? JSON is actually kind of big. JSON is big. CSS as CSS, less. I imagine that's not the terminal program. HTML, and Markdown. You can use it for Markdown. I imagine there are more languages that it supports, right? Is there like languages that I support? That would be useful to just straight up see. Because Prettier takes quite some seconds to load. Okay, let's be real there. How often do I need a formatter? Like, for real, like, is that particularly useful to me? Or is it more annoying to having to specifically enable it every time I open a new project? And this should also be disabled. Oh my god, stop meowing. Alright, so VS Code NeoVim I use always, so that naturally stays. Prettier, I will, so here it should indeed work, but enable workspace. So here I actually do need it. It's not that often that I actually need a formatter. This always, this, yeah, if I'm like making a README file for one of the projects, this is useful and doesn't take too much. Yeah, Lua, we disable overall, but enable here. This always. Same goes for fish. We disable but enable, but only here. Even better, toml, we once again disable overall, because I don't really work with toml that often. Yeah, and we will enable it in the workspace of Rust. Code snap is useful. Oh, this, yeah, obviously. We disable it, but enable here. Cool. And in a similar fashion, we enable workspace. We also enable it here. Yeah, basically now when I open a project, I pick what I want. Yeah, that's great. That's great. Code snap. Yeah, and prettier I don't need. Yeah, this will make things faster to boot up. And I work with all types of shit in this like main project. So having pretty much everything, but not quite, makes sense. Okay, where were we? Is sum. So let's define a variable. Let nummy sum5 print nummy is sum, but that's a boolean. Can I like toString? I don't know how to convert types yet, so. But this is a thing. Oh, right. So if nummy is sum, print, yep. What's the error? Format argument must be a string. Huh? I don't get it. Oh. Because to make the linter work correctly, I need to save first. Yeah, so once I see some errors, save and then check. A very important thing to remember. Let's car this. Cool. That is cool. That is very cool. Is sum and returns true if the option is a sum and the value inside of it matches a predicate. Oh, that's cool. Huh. That's cool. Is none. I would rather that be in syntax, to be fair. Like, if something, keyword is, and then the type, rather than having methods. I find when languages do it like that, it feels a bit more annoying. Technically, it doesn't matter that much, right? But feels annoying. So, is none as the ref. Oh, converts from this to this. as mutable. Huh, that's pretty cool. So reading docs is actually also viable for Rust when, yeah, it's similar to AutoHotkey actually in this sense, that you can actually like go ahead and just read the docs for as long as you want, and it's going to be useful for you. That's great. That's amazing. So the docs are great. Becoming familiar, or actually, we can something docs, and I don't remember what they are. Doc. Jesus, it took a long time. Rust up docs. Okay. The Rustonomicon, Jesus. Yeah, this is a file. Where's the like literal documentation? Okay, what else do we have in Rust up? Or actually, yeah, Rust up docs, and then help me please. Topic. Oh, that's cool. Oh, wow. Sure. Rude. FN. That's nice. Okay, what else do we have there? Path. Only print the path to the documentation. Toolchain. So that's how you search for different things, and then you have the page that you just search for. Okay, alloc, the Rust core location and collections library. Book, the Rust programming language book, the cargo book. Oh, that's interesting. The Rust core library, the Rust edition guide, the dark arts of advanced and unsafe Rust programming. That sounds way too epic. The Rust reference. Rust by example. Rust C. Rust doc, documentation generator for Rust project. STD, standard library API documentation. Okay, so we can do root, and I immediately forgot, where were we? STD. You get those by having sex. Boop. All right, cool. So we can just search here. Is there something better than STD? Like overall, just open the docs for me, please. Like the docs, not some weird book, not some fucking dark arts of advanced and unsafe Rust programming. Literally just the docs, please. Test support code for Rust C built-in unsafe blah blah blah. Unstable book, the embedded Rust book. I guess STD is the best I can get, right? Config. So root D will be STD. Makes enough sense for me. So now we have a way to easily open the docs without specifically searching for something. I feel like that might come up. In general, in order to use an option T value, you want to have code that will handle each variant. You want some code that will run only when you have a some T value, and this code is allowed to use the inner T. You want some other code to run only if you have a none value. and that code doesn't have a value available. The match expression is a control flow construct that does just this when used with enums. It will run different code depending on which variant of the enum it has, and that code can use the data inside the matching value. Okay, that's exciting. The match control flow construct. Rust has an extremely powerful control flow construct called match. They always say it. I guess, yeah, Rust always says it. Like, it's just a match statement. It's just a switch statement. And you call it, like, extremely powerful control flow. Like, bro, it's not that special, right? Like, it's just a switch case. And you say it's an extremely powerful. You could do the same thing with if else's, right? You kinda shouldn't, but you can. It allows you to compare a value against a series of patterns and then execute code based on which pattern matches. Now, the fact that they're using the word pattern instead of value or expression, now that's interesting. They might actually be not lying here. Patterns can be made up of literal values, variable names, wildcards, wow, and many other things. Covers all the different kinds of patterns and what they do. The power of match comes from the expressiveness of the patterns and the fact that the compiler confirms that all possible cases are handled. And if you don't, it will scream at you, I imagine. Think of a match expression, and what's cool about it is that it's an expression that I love. That kind of decision is severely underused, where if statements and switches are statements, which is just a shame, which brings some people into using ternary operators more often than they should. As being like a coin sorting machine, coin slides down a track with variously sized holes among it. Oh my god, Among Us, Among Us, Among Us. Oh, along it. Oh, I misread. And each coin falls through the first hole it encounters that it fits into. Oh, I see. In the same way, values go through each pattern in a match. Once again, it's just explaining a switch statement. And at the first pattern, the value fits, the value falls into the associated code block to be used during execution. Speaking of coins, let's use them as an example using match. We can write a function that takes in an unknown US coin and, in a similar way as the counting machine, determines which coin it is and returns its value in cents. As shown there. So we use an enum here, interestingly. Yeah, it makes sense to be using an enum. Just kind of, I still expect structs pretty much always, and don't fully recognize the full power of enums. That's like very new to me. Like, I've seen them around in C#, but I don't really use them at all, pretty much. So it can be a penny, a nickel, a dime, a quarter. You pass a coin, value in cents. Fair enough that it uses this type, technically. But like, what if you have a coin that's over 255, but you don't though? Fair enough, fair enough. And if that exists, well, just change the code. Fair enough, okay. Match coin. I do quite love this. And then it's automatically returned. Let's break down the match in the value and sense function. First, we'll list the match keyword followed by an expression, which in this case is the value coin. This seems very similar to a conditional expression used with if, but there is a huge difference. With if, the condition needs to evaluate to a Boolean value. Ah, that's huge actually. That's mega huge. I'm gonna start misusing matches so badly. But here it can be any type. The value of coin is in this example is the coin enum that we defined on the first line. So these are types, or I guess subtypes. No, they're types. They're different types. So these are patterns? Question mark? We'll see, I guess. Is just the value 1. Each arm is separated from the next with a comma. When the match expression executes, it compares the resultant value against the pattern of each arm in order. If pattern matches the value, the code associated with that pattern is executed. If that pattern doesn't match the value, execution continues to the next arm, which as in a coin sorting machine. Oh, much. We can have as many arms as we need. Our match has 4. Okay, the code associated with each arm is an expression. True. And the resultant value of the expression in the matching arm is the value that gets returned for the entire match expression. And it makes it so like elegant in a way. Just a single, you would think, statement, but no, it's an expression that I much love. Yeah, we don't typically use curly brackets if the match arm code is short, as it is in here. Oh, I see what you mean. Where each arm just returns a value. If you want to run multiple lines of code in a match arm, make a function maybe? Well, no, it depends on the situation, obviously. You must use curly brackets, and the comma following the arm is then optional. That's actually mega cool. For example, the following code prints lucky penny every time the method is called with a coin. So is every penny lucky? That's interesting, but still returns the last value in the block. That I still mega love. The fact that the return keyword you will now pretty much only see in guard clauses. Patterns that bind to values. Another useful feature of match arms is that it can bind to the parts of the values that match the pattern. What? This is how we can extract values out of enum variants. Okay. As an example, let's change one of our enum variants to hold data inside it. From 1999 through 2008, the United States minted quarters with different designs for each of the 50 states on one side. No other coins got state designs, so only quarters have this extra value. We can add this information to our enum by changing the quarter variant to include a US state value stored inside it, which we've done here. Interesting. So now we define basically a bunch of types and a parent type of it. And now we have to pass that type to it and its value. That's interesting. Let's imagine that a friend is trying to collect all 50 state quarters. While we sort our loose change by coin type, we'll also call out the name of the state associated with each quarter so that if it's one our friend doesn't have, they can add it to their collection. So we're just giving free money to our friend. Sure. In the match expression for this code, we add a variable called state. To the pattern that matches values of the variant coin quarter. When a coin quarter matches, the state variable will bind to the value of that quarter's state. Then we can use the state in the code for that arm like so. Okay, so this is the type, but now it has a value. And similarly to how we store it, we extract it similarly as well. And now it's just a variable. That's great. That's quite nice. And because we derived debug, we can use this syntax to see it fully. If we were to call coin quarter of this state, see, I don't quite like this function now because we need to specify an unnecessary information. Like if we're getting value in cents, all quarters have the same value. What type they are doesn't matter. But once again, yeah, it's just an example. But if you take this example literally, it wouldn't be good code because I guess side effects. Coin would be a coin quarter US state Alaska. When we compare that value with each of the matching arms, none of them will match until we reach coin quarter state. At that point, the binding for state will be the value of Alaska. We can then use that binding in the print line expression, thus getting the inner state value out of the coin enum variant for quarter. Matching with option T. Are we gonna get option coffee? In the previous section, we wanted to get the inner T value out of the sum case when using option T. We can also handle option T using match. Yeah, that's what I thought, as we did with the coin enum. I love the exclamation marks that they often use. It's very cute. Instead of comparing coins, we'll compare the variance of option T, but the way the match expression works remains the same. Let's say you want to write a function that takes an option I32. And if there is a value inside, adds 1 to that value. If there isn't a value inside, the function should return the non-value and not attempt to perform any operations, meaning it also returns yeah. This function is very easy to write things through match and will look like this. Yeah, fair enough, I guess. A bit too much syntax for something this simple, but at the same time, it's not like it's better in a different language. At the very least, you're required to solve it. That's very important. But interestingly, you also, like, if you specify something as nullable, pretty much, you now have to provide a nullable value, even if you don't want it to be that. Let's examine the first execution of +1 in more detail. When we call plus 1, 5, the variable x in the body of plus 1 will have the value sum 5. We then compare that against each match arm. It's not none, so we continue. Then sum 5 value doesn't match the pattern none. Yeah. Does sum 5 match sum I? It does. We have the same variant. The I binds to the value contained in sum, so I takes the value of 5. The code in the match arm is then executed, so we add 1 to the value of I. Oh, interesting. That basically it gets extracted and then intracted, which is definitely a word, trust me, to create a new sum value with our total 6 inside. Now let's consider the second call of plus 1, where x is none. We enter the match and compare it to the first arm. It matches. There's no value to add to, so the program stops and returns the none value on the right side of this. Because the right arm matched, no other arms are compared. Combining match and enums is useful in many situations. You'll see this pattern a lot in Rust code. Match against an enum, bind a variable to the data inside, and then execute code based on it. It's a bit tricky at first, I can see that. And once you get used to it, you'll wish you had it in all languages. Are you sure about that? Really? It's consistently a user favorite. Really? I am not quite sure yet why, you know? I don't fully comprehend how this is that much different from handling null in other languages. Aside from the fact that there you don't have to. It may be a warning, it's pretty much never an error. I imagine in Rust it will be, or at least I hope that's the case. Because if it isn't, what's the difference? Let's compare. Fuck, it's fucking using spaces. God damn it. I like how it looks, by the way. The types being that color. That's cool. Looks better in person. Okay, so this. Let's. Oh, I know what I'm gonna use. F, and this one is V. Cool, right? That's multiple windows, not just editors, multiple windows. Okay, so let's create a function plus 1 that takes in x and returns it later. Well, first of all, let's ignore that we can't return null. Imagine I'm doing this in C#. Opening a C# project is just way too slow, so that's why I don't want to. Okay, so plus 1. If x, or rather if not is set, x, return unset. Let's once again imagine that we can do that. You can't. Return x. I don't get it. Tell me, how is this better than this? I don't see the difference. Like, if we could return unset, then like here we go. The difference being the fact that you have to explicitly specify every variable or parameter, I guess, that can be null and you have to explicitly return a thing that can be null as well. But that's more the thing of the language rather than the implementation of null. Otherwise, it's very similar. Which is why I'm like unsure why they're praising it that much. Like, isn't it kind of similar? I don't quite get it. Like, yeah, cool, but more so because of the overall type system, or rather than the implementation of null. The implementation of null by itself is very like simple. It's what you would expect. It's the type system overall that requires you to basically specify it. I don't get it. Where were we? Combining match and enums is useful in many situations. Oh yeah. Yeah, I don't get it. All right. I'm gonna go cook. So I'm gonna save this. Oh, we don't need this. And regl. Oh wait, no, regl. Boop. New link. And we're gonna continue sometime. I don't know exactly when. So goodbye.